Right. Okay, great. So I showed you the sort of output method, and I'm going to show you the sort of from the looking at it from the inputs. So you can also, it's just another way of looking at it, and this is the way it's done in your text. So let's kind of come here. So what we're really saying here is, let me see if I can clear out this. Oh, I can't erase the ink here now. Okay, great. So what are we saying here? We're saying that we expect you to lose 10%, you remember that, of input. So which means that if you're coming out with output of 15408, we expect you to put some input in, let's just call it X, lose 10% of that, 10% of X, and get 15408. This is what we're expecting you to put this in. So the question is, what is this thing we're expecting you to put in? And we can now compare that thing to what you did put in. And that's all we're really doing. And it's exactly the same thing. It's the same process. We're just this time looking from the point of view of inputs to understand, to see what's going on. So therefore, if we are sort of saying, well, what is X minus 10% of X giving 15408, if you like, or this is therefore 90% of X is equal to 15408, and therefore X is equal to 15408 divided by 0.9, which gives us a healthy 17,120. So the argument is we expected you to put in 17,120, but you ended up putting in this thing here, which I believe came to 19,153. So let's now analyze that and break that up a little. So what we're saying here, we have S1, S2, S3. We expect you to put 17,120. You ended up putting in 19,153. And so therefore we have yes, so again we do this at the standards that we were talking about. So this is 8/16, the mix, the standard mix, 5/16 and 3/16. And when I split this up, these guys up that way, I will get 8/16 times this is literally half of that. That's 9576.5. 5/16 times this, sorry, forgive that sound, I need to put that down, 5985.3, and then 3/16 times this is 3591.2. And again, yes, this is what you actually did. Remember, again, my focus is literally on these guys. I'm literally on totals here. So I'm not interested in the actual mix per se. I'm just interested in output. So I'm trying to compare inputs to outputs. So in effect, when I split this up according to the standard mix, I get 95. Sorry. This, what I've just done here is the actual mix. So this is the actual mix. So this, I'll just erase this and I'm just gonna erase. Oops, all right. Let me just erase this. I'll just start again. I'll just do it again. Oops. No, just with a pen. Oh, pen. Okay, so in terms of my standard mix of 17,120, half of this is 8,560. 5/16 of this is 5,350, and 3/16 of this is 3,210. Now, this is the actual total amount, but at the standard mix, of course, which is just what I'm looking for, that was what I did earlier on, 9576.5. This was 5985.3, and this was 3591.2. I'm just going to change my pen color now. So what we now have is that you have used, so you used more right across the board. So you used more here, you used more here, you used more here. The question is, what did you use? What is the variance? What is the yield? VAR, yield variance. So here we have 1016.5 adverse. We have here, subtracting this from this, we have 635.3, and here we have 381.2. And I know what the cost is of each of these. I mean, it's 0.3, 0.5, and 0.4. And when I multiply this together, of course, because this is the cost of each kilogram, I get 304.95. Here I get 317.2. 0.65, and here I get 152.48, and therefore I have a total of 775.08. Exactly the same answer as I had before. So this is looking at it from the feature or the point of view of input, if you like, or how well inputs have, or just really looking at the variation in inputs. But we're talking about efficiency. It's not looking at the mix. So we have to keep the mix standard, keep that constant, if you like, as you went along. So please play around with both methods. I think it's essential so you're comfortable with both. The other thing I thought about this question where you almost were forced to use this was that they talked about producing this in you needed this to produce a single batch. So you had to kind of mentally kind of keep that in mind if you wanted to use my first method, the output method. I think you're always safe with this method, this kind of method I've just done now. I think so, because here, if you do it this way, which as you practice it, you'll get used to it. You will always, you're almost asking, you're looking at it from an input point of view, right? That's what I used. This is what I should have used, and then you can compare the difference. Okay, cool, great stuff. And and then I'll see you in the next video as we move into sales mix and quantity variances.